Welcome to Ocean Currents Part 3, talking about thermohaline circulation. So this is going to be the connection between the surface ocean and the deep ocean. Remember, we talked about the difference between surface currents and deep water currents. So surface currents are anything that's in the upper 10% of the ocean, about 400 meters. This is impacted by sun, this is impacted by air temperature, this is impacted by runoff from the continents, okay? And those are all basically the surface currents that we think of, that we use, that are important for shipping purposes, when we think about fish migrations, and so on and so forth. Deep water currents are actually the majority of ocean currents, and they are based totally on temperature, not totally, majority on temperature changes and salinity changes, because both of these things, temperature and salinity, okay, impact density. All right, so if you remember way back when, at the beginning of the year when we were talking about water, maybe you don't, okay? As temperature, what happens when temperature goes up and something gets warmer? Does it rise or does it fall? Okay. Increased temperature means decreased density. And I'm sorry that my writing is not going as well as it could have. Okay. So increased temperature, warmer water is less dense than colder water. The opposite is true for salinity. So increased salinity, which is basically just dissolved solids, salt, okay, but anything that's a dissolved solid, all right, causes an increase in density because we're putting more stuff in the water. The more stuff in the water, the more dissolved stuff in the water, the heavier the water is going to be, okay? So what happens with deep water currents is they're based on these changes in density that makes water heavier, quote unquote, denser, or lighter. So when it's denser, it's going to fall to the bottom of the ocean. When it's lighter and less dense, it's going to rise to the top of the ocean. And then there's going to be things like the Coriolis effect is going to help, wind's going to help, all right, all of those things that go into upwelling and downwelling. Scientists refer to this as the global ocean conveyor belt because what's happening is water is constantly moving. If you remember back from the first lecture in this series talking about surface currents, we talked about the ducks and the sneakers and the hockey gloves and all of that stuff that end up getting transported around the globe. So scientists originally, that's why we have this whole idea of the seven oceans or whatever. Okay, the different seas, sailing the 7 seas. Okay, people originally thought these were self-contained little pockets of water. Okay, and we also used to believe that salt water was only on top, and then it was fresh water underneath it somehow. This is what happens in science. You go out and you look at things and you learn more things, and it's like, whoa, okay. But now, as we continue to study and we have better instruments and we do more and we can get deeper and so on and so forth, we're actually finding more about this ocean conveyor belt where basically if a water particle was to enter into this system, let's say here in this spot in the South Atlantic, okay, it would travel these various these various currents. So if it entered here in this warm current, all right, would come up the Gulf Stream, which comes across near New Jersey, okay, goes up. It's what keeps England kind of warm considering its latitude because it's way higher in the globe, but it actually has very warm, rainy temperatures. All right, and then as it gets here, it starts to cool off and it starts to sink. Okay, and then it sinks again up here, Greenland, Iceland, because now it's getting colder. So as it's getting colder, it's less dense, and so it sinks and then follows this around until it reaches a point here of upwelling, which if you remember from the last lecture, this is going to be a spot full of nutrients. Okay, food webs would be really abundant here. All right, and then it continues on its journey. And so what happens is the surface currents tend to be warm, They tend to have a lot more gases in them, oxygen, carbon dioxide, from the organisms that are able to live in those top 10% of the water, and then also the ocean and atmosphere interactions. And then what happens is they cool off, they start to sink, and they become saltier. So they turn into the deeper currents. Surface currents can play a significant role in transporting heat energy, and we discussed that a little bit last lecture with El Nino and La Nina. Okay, and as that switch, that oscillation happens, as that situation changes, it changes the position of the warm water versus the cold water. Currents also involved with gas exchanges, nutrient exchanges. We talked about that with upwelling and downwelling. So remember, upwelling brings up that nutrient rich, basically full of fertilizer, decaying organic matter, both in the form of dead bodies and poop, basically. Okay, and then it brings that up, that acts like fertilizer. And then in other areas we have downwelling, where it brings that stuff down. It is involved in pollution dispersal, and then impacts on fisheries and other resources. So this is a normal process. This ocean conveyor belt is completely normal, and it changes where we might find certain organisms during the seasons, which we're going to talk a little bit about later this week. Seasonality of where organisms might be found. This is one of the reasons why we talked a couple months ago, or however long ago it was at this point, about the sea turtle migration. We talked about homing and navigation and migration. So these currents are part of the reasons why animals migrate during the course of the year, and also use them to help migrate. So when it's a normal situation, we might find blue whales in one spot of the world where they're eating a lot, because the upwelling actually brings up a lot of organisms, has a really strong food web. Blue whales eat krill. They're baleen whales, so they'll eat krill and phytoplankton and zooplankton and stuff like that. So what happens is the upwelling will create that, but then they might go somewhere else to spawn. So you'll see seasonal changes in whales that way. So when it's normal, it creates normal patterns that we can follow. However, when things like El Nino happen and it changes the quote unquote normal situations, it has dramatic impacts on fisheries and other resources. So thermohaline circulation is based entirely on changes in temperature and salinity, which again, like I said, changes in density. Okay, so surface water tends to be warmer, all right, less dense, highly oxygenated, all right, and then what it does is it ends up getting cooler and sinking, okay, and that where it becomes, that's where we end up seeing those increased nutrients. But what happens is that water, as it gets denser, it actually starts to fall down to the bottom of the ocean. And thermohaline circulation is driven by these changes in density. So again, we call this the Great Ocean Conveyor Belt. And these currents can shift with seasons as well, exactly where they are. So the Gulf Stream here, okay, can come a little bit closer to the U.S., come a little bit further down, or it can move a little bit further up, and so on and so forth. Okay? All right. I will talk to you later. Have a great day.